Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic vector calculus. Today we are going to discuss differential length, area and volume, line surface and volume integrals, del operator, divergence theorem and Stokes theorem. The differential length, area and volume are represented by dl, ds and dv. These three parameters play key role in vector calculus. They are calculated in Cartesian, cylindrical and spherical coordinate systems. But here in this class we are going to derive dl, ds and dv in Cartesian coordinate system only. The differential length vector in Cartesian coordinate system. In Cartesian coordinate system, a point P is represented by x, y and z. X is the distance along x-axis, y is the distance along y-axis and z is the distance along z-axis. And here the differential length vector dl is equal to dx ax plus dy ay plus dz az. Here ax, ay and az are the unit vectors along xyz axis respectively, and dx, dy and dz are differential length elements along xyz axis respectively. Differential surface or differential normal surface. Here before calculating the differential normal surface, let us discuss about the Cartesian coordinate system. Here x, y and z axes are given, and it is the differential length along x-axis, differential length along y-axis, and it is the direction of y. And for this case, the differential normal surface can be represented as dx, dy and az hat or cap, or this can be represented as dy, dz along ax, dz, dy along dz, dx along ay. You can refer to the given figure. And for volume integral, or for differential volume, the dv is equal to dx, dy and dz. It is a scalar quantity. The line surface and volume integrals, in that the first one is line integrals. Line integral is calculated over a line or curve. Here the line integral over a line from point A to point B over a vector a bar, and here dl is the differential length vector. Here vector a bar is given as ax hat, ay hat plus az hat or cap. dl is dxax, dy ay plus dz az. Now you can calculate line integral over a closed path, that is line integral over a closed path vector a bar dot dl. The line integral from point A to point B over a vector is the integral of the tangential component of vector a bar along the length L. The second is surface integral. It is calculated for 2D surface. The surface integral of a vector field of a vector is given by double integral of a bar dot ds. ds is the differential normal surface, and for a closed surface, uh, the surface integral can be calculated as closed surface integral of vector a bar dot ds. In general, closed surface looks like open volume. Closed curve looks like open surface. You just remember this key point. Volume integral, it is calculated for three-dimensional surface. The volume integral of a scalar point function pi calculated over differential volume. The next is del operator. It is represented by this symbol. It looks like the reverse triangle. Del is equal to dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. The operator is useful in defining the gradient of a scalar can be written as del v. The divergence of a vector a bar written as del dot a. The curl of a vector a bar written as del cross a bar. The Laplacian of a scalar v written as del square v. Gradient of a scalar, del v is equal to dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. Just now we discussed about del is equal to dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. Here del v is equal to dou v by dou x ax, dou v by dou y ay, dou v by dou z az. In the same way, if we perform the dot product between the del operator, del is equal to dou by dou x ax plus dou by dou y ay and dou by dou z az, and the vector a bar is equal to ax plus ay plus az. We will get the value associated with the divergence of a vector. The divergence of a vector a bar is equal to, it is the dot product between the del operator and vector a bar, that is dou ax by dou x plus dou ay by dou y plus dou az by dou z. The curl of a vector a bar, it is represented in the determinant notation, that is ax ay az, dou by dou x, dou by dou y, dou by dou z. Ax, ay, az are the components of vectors along xyz axis respectively, and its determinant expansion is given by this equation, and the gradient, divergence and the scalar are given in a Cartesian coordinate system. In the upcoming classes, we'll discuss the representation of gradient divergence curl in spherical and cylindrical coordinate systems. Divergence theorem, it gives a relation between double integral and triple integral. Uh, States that the volume integral of divergence of a vector field A bar taken over any closed volume is equal to the integral of vector A bar around the closed surface surrounded by the volume V. That is closed surface of A bar dot ds. As we discussed in the previous slide, closed surface resembles a open volume, and it is del dot A dV. That's what I wrote here, SV dot surface to volume divergence. This is the way of remembering the equation of divergence theorem, or simply you can call it as trick SV del dot, that is surface to volume del dot. Closed surface integral of A bar dot ds is equal triple integral of del dot A dv. Stokes theorem gives the relation between line integral and surface integral, and here the trick is ls del x, that is closed line integral of A bar dot dl. Closed line resembles open surface ls del cross, that is line to surface del cross A dot ds. Here ds is the differential normal surface. I will read out the statement of Stokes theorem. The surface integral of curl of a vector field A bar taken over any surface S is equal to the line integral of A bar around a closed contour or curve. Ls del cross. This is the trick to remember the equation of Stokes theorem. Refer to sample problem. Another sample problem. Thank you. We will meet with the next lecture.